Hello dear students, in this video we will revise some important questions from Modular Arithmetic, which is the first topic from the first unit, which is numbers quantification and numerical applications. So here we have the first question. This question was given in last year's term 1 board exam paper. So we will see the questions from last year's board exam paper and sample question paper, in addition to all other questions which are there under the topic Modular Arithmetic and Congruence Modulo. The first question, if 100 congruent to x mod 7, then the least value of x is. So here we have to find the value of x for which 100 is congruent to x mod 7. Now we know that if a is congruent to b mod m, then a mod m is equal to b mod m. So here if we are able to find 100 mod 7, then we will be able to find what is x. So when we divide 100 by 7, the remainder is, it is 2. So 100 mod 7 is equal to 2. So we have 100 congruent to 2 mod 7. So the value of x is 2. So the correct option is option A, which is 2. The next question, this is an additional question. If x is the least non-negative integer satisfying 218 congruent to x mod 7, then x square plus 1 is. So here again we have to find 218 mod 7 to find the value of x. So when we divide 218 by 7, we get the remainder as 1. So here 218 mod 7 is 1. So from this we have x is equal to 1. So x is equal to 1. So x square plus 1 will be 1 square plus 1, which is 2. So the correct option is option A, which is 2. The next question, the remainder when 5 raised to 61 is divided by 7 is. Again this question was given in last year's term 1 board exam paper. We have to find the remainder when 5 raised to 61 is divided by 7. So we have to use the property, if a congruent to b mod m, then a raised to k congruent to b raised to k mod m, where k is a natural number. So here we have to find 5 raised to 61 mod 7. Now 5 square, it is 25. So 5 square is 25. 25 congruent to 4 mod 7. Then if we take 5 cube it is 125. When we divide 125 by 7, we get the remainder as 6. So 125 congruent to 6 mod 7. When we divide 125 by 7, we get the remainder as 6. So 5 cube is congruent to 6 mod 7. If we consider 6 square is 36. That is 5 cube the whole square congruent to 6 square mod 7. But if we see 6 square, it is 36. 36 mod 7 is 1. So we have 5 raised to 6 congruent to 1 mod 7. This is because 36 mod 7 is equal to 1. So we need 5 raised to 61, that is the remainder when 5 raised to 61 is divided by 7. We got 5 raised to 6 congruent to 1 mod 7. So 5 raised to 6 the whole raised to 10 congruent to 1 raised to 10 mod 7. This is using this property. If a congruent to b mod m, then a raised to k congruent to b raised to k mod m. So from this we get 5 raised to 60 congruent to 1 mod 7. We need 5 raised to 61. So 5 raised to 60 into 5, it is congruent to 1 into 5 mod 7. Therefore 5 raised to 61 congruent to 5 mod 7. or 5 raised to 61 mod 7, it is equal to 5. So when we divide 5 raised to 61 by 7, we get the remainder as 5. So the correct option is option C, which is 5. The next question, these are additional questions. The units digit in 11 raised to 24 is. So here again we have 11 mod 10. If we want to find the units digit, then we have to find mod 10. 11 mod 10 is 1. So we have 11 congruent to 1 mod 10. 11 raised to 24 congruent to 1 raised to 24 mod 10. So from this we get 11 raised to 24 congruent to 1 mod 10. So the correct option is option 1. Even otherwise, if we consider 11 square, it is 121. So the ones place will be 1. Then 121 into 11. Again the ones place will be 1 and so on. So here the units digit in 11 raised to 24. It is 1. Next we have units digit in 3 raised to 300 is, we have to find the units digit in 3 raised to 300. So when we have questions of this type, that is we have to find 3 raised to 300 mod 10. When we have questions of this type, we have to find some value which is congruent to 1 mod 10. So what power of 3 which when divided by 10 will give the remainder as 1, that we have to check. So if we consider 3 raised to 4, that is 3 raised to 4 is 81. 81 mod 10 is 1. So when we have questions of such type, we have to see where we will be able to get the remainder as 1 of mod m. So here we are asked to find the units digit. So we need to find mod 10. If we consider 3 raised to 4, which is 81, it is congruent to 1 mod 10. Or when we divide 81 by 1, we get the remainder as 1. We need 3 raised to 300. So it is 3 raised to 4, the whole raised to 75. It is congruent to 1 raised to 75 mod 10. 3 raised to 4 whole raised to 75 is 3 raised to 300. 1 raised to 75 is 1 mod 10. So from this we get 3 raised to 300 mod 10. It is equal to 1. So if we want to find the units digit, we have to find mod 10 and we get the answer as 1. So the units digit in 3 raised to 300, it is 1. So the correct option is option B. The next question, the value of the value of multiplication modulo 8 to 5 into 11 is, where we have this symbol which represents multiplication modulo. This question was given in last year's sample question paper. So here we have multiplication modulo m of a into b. It is equal to ab mod m. So here we have multiplication modulo 8 to 5 into 11. So it is 5 into 11 mod 8. So 5 into 11 is 55 mod 8. When we divide 55 by 8, we will get the remainder as 7. So the correct option is option D, which is 7. Next question, the value of x in the set 0, 1, 2 up to etc. 10 satisfying 3 minus x congruent to 5 mod 11 is. So here we have to find the value of x which satisfies this relation, that is 3 minus x congruent to 5 mod 11. So here 3 minus x congruent to 5 mod 11, we can write this as 3 congruent to x plus 5 mod 11. So here if a congruent to b mod m, then a mod m is equal to b mod m. So here we have to find x plus 5 mod 11. It should be equal to 3, since 3 mod 11 is equal to 3. So among these values 0, 1, 2 till 10, here what value when we substitute, we will get the remainder as 3. So if we put each of these values and check, only when we put x as 9, if we put x as 9, then 9 plus 5, it is equal to 14. 14 mod 11 is equal to 3. So the correct option is option B. So when we put x as 9, we will get 9 plus 5, which is equal to 14. When we divide 14 by 11, we will get the remainder as 3. Since we need to find x such that x plus 5 mod 11, it is equal to 3. So the correct option is option B, which is 9. The next question, if the present time is 8:40 a.m., then the time after 876 and half hours will be. So here this question was also given in last year's sample question paper. So they have given the present time as 8:40 p.m. We have to find the time after 876 and half hours. Here we cannot find modular arithmetic for real numbers. So we have to leave this half and we have to find 876 mod 24. And then after finding the answer, what it is, in that let us add this half an hour, which is 30 minutes. So 876 mod 24, when we divide 876 by 24, 324 72, then 624 is 144, remainder is 12. So 876 mod 24 is 12. So 876 hours after 8:40 p.m. is equivalent to 12 hours 30 minutes after 8:40 p.m. So 12 hours after 8:40 p.m. is 12 hours after 8:40 p.m. is 8:40 a.m. and 30 minutes after 8:40 a.m. plus 30 minutes, it is 9:10 a.m. So the correct option is option B. So this is how we have to go about if we are given real numbers to find the time after particular hours. This is an additional question. It is 7 p.m. correctly. What time will it be in next 1500 hours? So here we need to find 1500 mod 24. So when we divide 1500 by 24, we get the remainder as it is 12. So 1500 mod 24 is 12. So 1500 hours 7 p.m. is equivalent to 12 hours after 7 p.m. So it is 7 a.m. So the correct option is option A, which is 7 a.m. These are additional questions in modular arithmetic. So this is called addition modulo 5. So if we have addition modulo m to a plus b, it is nothing but a plus b mod m. So here we have to find addition modulo 5 to 12 plus 6. So it is 12 plus 6 mod 5. Here 12 plus 6 is 19. When we divide 19 by 5, we get the remainder as 4. So addition modulo 5 to 12 plus 6, it is equal to 4. Next question, find subtraction modulo 12 to 20 minus 12. So if we have subtraction modulo, it is given by subtraction modulo m to a minus b. It is a minus b mod m. So here subtraction modulo 12 to 20 minus 12. It is 20 minus 12 mod 12. 20 minus 12 is 8. So it is 8 mod 12. So here we can see that 8 is less than 12. So we have any number which is, say for example, x mod m. So x mod m, it will be equal to x if x is less than m. So here we can see that 8 is less than 12. So 8 mod 12, it is equal to 8. So here we have subtraction modulo m to a minus b. It is equal to a minus b mod m if a minus b is more than m, and it is equal to a minus b if a minus b is less than m. Here we can see that 8 is less than 12. So subtraction modulo 12 to 20 minus 12, it is equal to 8. The last type of question, find the equivalence class of 4 mod 7. So we have studied about equivalence class. So here we need to find the equivalence class of 4. It is nothing but set of all A belong to Z such that A congruent to 4 mod 7. So here we have to find all those integers which when divided by 7 will give the remainder as 4. That is equivalence of 4. So when we divide 4 by 7, we will get the remainder as 4. Then the next number is, that is 4 mod 7 is 4. And next we have 4 plus 7, which is 11. 11 mod 7 is also 4. And next we have 11 plus 7. 18 mod 7 is 4. Next we have 18 plus 7, which is 25. 25 mod 7 is 4, and so on. Similarly, if we want to find those numbers which are less than 4, which when divided by 7 will give the remainder 4, it is 4 minus 7 equal to minus 3 mod 7. The answer is 4. That is when we divide minus 3 by 7. Quotient is minus 1. The remainder is 4. And next we have minus 3 minus 7 equal to minus 10 mod 7. Again it is 4. Next we have minus 10 minus 7, which is minus 17 mod 7. Again the remainder is 4. Like that it goes the other way. So this is equal to, here we have 4, then 11, then 11 plus 7 18, then 18 plus 7 25, up to etc. And here we have 4 minus 7 minus 3, then minus 3 minus 7 minus 10, then minus 10 minus 7 minus 17, then it goes on. So the list goes on both the negative side and the positive side. So this is how we go about in finding the equivalence class. And here we have some more questions from sample question paper. If x congruent to minus 4 mod 3, then a solution for x is. So here we have to find the value of x which is congruent to minus 4 mod 3. So here if we have x congruent to minus 4 mod 3, then we can write x plus 4 congruent to 0 mod 3. So here among these values, if we put each of these value and check. So if we see minus 2 plus 4, 2, it is not divisible by 3. Then if we consider 12, then 12 plus 4 is 16. It is again not divisible by 3. If we consider 19, 19 plus 4 is 23, which is not divisible by 3. If we consider 35, 35 plus 4, which is 39. So 39 mod 3, it is 0. So the correct option is option D. So the value of x is, it is 35. Since 35 congruent to minus 4 mod 3. Next question, this is an important theorem in congruence modulo. Let m belong to the set Z of positive integers. Consider the relation Rm defined as A related to B if and only if A congruent to B mod m. Then Rm is. Now we have a theorem on this. We have seen that if A is related to B as A congruent to B mod m, then the relation is symmetric, transitive and reflexive. So here if a relation is reflexive, symmetric and transitive, then such a relation, it is called an equivalence relation. So this relation Rm, it is an equivalence relation. This question was also given in one of the sample papers. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you like this video, share it with your friends. Thank you for watching.